factoring trinomials with the leading coefficient of something else besides a 1. Okay? In this case, that number is a 3. All right? So in this problem, A is 3, B is 13, and C is 4. A, B, and C. Okay? When we're factoring a trinomial with another number besides 1 as the leading coefficient, it's similar to what we did factoring the other trinomials, but it's different. Okay? What we have to do here is we have to find AC. Well, do you see why we labeled them to begin with? Now we need to find AC. What is 3 times 4? Well, 3 times 4 is 12. And I also need to know B. And B in this case is 13. Okay, well, you remember how in the other examples things had to multiply to be the last term and add to be the middle. If you think about it, we did the same thing, because the last term is just C. Well, if the first term was 1, aren't I really finding AC? Isn't that really just the last term? Because the last term times 1 is just itself. Okay, so here it's just a little bit more involved. So I find what multiplies to be 12 and adds to be 13. Well, a lot of times it's helpful to write down the things that multiply to be 12, or multiplies to be AC, in this case 12. So 1 and 12, 2 and 6, 3 and 4. Those are the numbers that multiply to be 12. What set of these numbers add to be 13? Well, it's 1 and 12, right? So you're going to now rewrite. You're going to rewrite the problem, okay? And what you're going to do is you're going to start writing 3x squared, but you're not going to write 13x. You're going to split it the way you just figured it out, 1 and 12. But it's got that x with it, and you've got to keep the x with it. So you need to have plus 1x plus 12x. Okay, do you see how this middle term, these two terms have become this middle term, or this middle term has become these two middle terms? Does that make sense? Okay, and then I have the plus 4. Well, hopefully you recognize this as a polynomial with 4 terms, and we can factor this by grouping. Okay, so just look at the first two terms. What do the first two terms have in common? What are they both divisible by? X. What am I left with if I divide 3x squared by x? Well, I'm just left with 3x. What's left when I divide 1x by x? Well, I'm just left with 1. Now look at just the second two terms. What are the second two terms both divisible by? Well, they're divisible by 4. What's 12x divided by 4? Well, it's 3x. What's 4 divided by 4? Well, that's 1. Okay? Are both of my parentheses the same? Yes. If they're the same, I can go to my last step. What did I factor out of the first set? What did I factor out of the second set? And what did they have x in common? That is my answer. Okay, let's do another one. 2x squared plus x minus 15. So the first thing I want to do is label my A, my B, and my C. Now keep in mind, in this case A is 2, in this case B is 1. Remember, the x's don't come into play here. They tell you where A, B, and C are, but they really don't come into play. So AC in this case is negative 30. And in this case, B is 1. So what are the multipliers of negative 30? Well, 1 and 30, obviously 1 has to be negative. 2 and 15, 3 and 10, 4 doesn't divide into 30, and then 5 and 6. So which set of these multipliers am I going to use to get 1 when I add them together? Well, hopefully you see it's the 5 and the 6. If the 5 is negative. Negative 5 times 6 is negative 30. Negative 5 plus 6 is positive 1. Okay? Rewrite. Rewrite the problem and split the middle term into two parts. So I have 2x squared minus 5x plus 6x minus 15. Okay? Now factor it by grouping. Just look at the first two terms. What are the first two terms both divisible by? Well, they're only divisible by an x. If I divide or factor an x out of this term, I'm left with 2x. If I divide or factor an x out of this term, I'm left with minus 5. Now just look at the second two terms. What are they both divisible by? Well, they're both divisible by a 3. What's left when I factor a 3 or divide a 3 out of 6x? 2x. What's left when I divide a 3 into 15? Negative 5. Are both parentheses the same? Yes, they are. So I can go to my last step. What did I factor out of the first term? X. What did I factor out of the second term? Plus 3. What do they have in common? 2x minus 5. Okay? Now, so here's this question. 8x squared plus 10x minus 3. Well, A is 8, B is 10, and C is negative 3. AC is what we have to find first. And AC, A, 8 times negative 3, C, is negative 24. And B is 10. Okay? So, what multiplies to be 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's all. Yeah, that's all. Okay? So which set of these numbers am I going to choose to make a positive 10? Well, 4 and 6 is 10, isn't it? Except 4 times 6 is a negative 24, so I cannot choose 4 and 6. What I have to choose is 2 and 12 if the 2 is negative. Now rewrite. When I rewrite this problem, I split my middle term into two parts. 8x squared, and the two parts are the two parts that I just found, right? Minus 2x plus 12x, and then minus 3. Factor by grouping. Just look at the first two terms. What's divisible? What are the first two terms divisible by? 2x. What's left? If I divide this by 2x, I'm left with 4x. If I divide this by 2x, I'm left with minus 1. Okay? Now just look at the second two set of terms. Both of these numbers are divisible by a 3. What's left? 4x. 12x divided by 3 is 4x. And 3 divided by 3 is 1. Are both parentheses the same? Yes. So my last step, I factored a 2x out of the first two terms, factored a 3 out of the second two sets of terms, and the 4x minus 1 is what they had in common. Okay? One more example for you, because I want you to see where they can go. Okay? I want you to see what some of them might look like. I don't want to try to hide any hard ones from you. Okay? 20x squared plus 43x plus 21. All right? So A is 20, B is 43, C is 21. AC is 420. B is 43. Okay? Now at this point, I would break out my calculator. Okay? And I would just start figuring this out because I've got to find multipliers of 420 that add to be 43. Okay? So let's start easy. 1 and 420, 2 and 210, 3, let's just go here. 420 divided by 3. Well, that's 140. By 4 is 420 divisible by 4. 105. I can tell 420 is divisible by 5. And that's 84. 6. Well, I know it's divisible by 2 and 3, so hopefully it's divisible by 6. So that's 70. Remember, what I'm trying to keep in the back of my mind is I've got to find a sum of 43. And since everything is positive up here, I know that I'm just going to be able to add these two numbers together and to get 43. But I haven't found that yet, so I have to keep going. 420 divided by 7. So 7 and 60. 420 divided by 8. That doesn't work. That's a fraction. Okay, 420 divided by 9. Nope, not divisible. 420 divided by 10 is 42. We're getting closer. 420 divided by 11. Not divisible. 420 evenly anyways, divided by 12. 12 and 35. 12 and 35. If I add those together, I get 47. So again, I'm getting closer. 420 divided by 13. Nope. 420 divided by 14. 14 and 30. 44. So close. 420 divided by 15. 15 and 28. Success. 15 plus 28 is 43. Okay? So now, rewrite. Alright? So I'm going to go to 20x squared, split my middle term. Not going to be 43 anymore. It's going to be 15x plus 28x. And for the record, it doesn't matter what order you write these in because it doesn't matter what order we add in. You'll still get the same factors, just so you know. Okay? Plus 21. So now, group. Group the first two. Both of the first two terms are divisible by 5x. So I'm left with 4x plus 3. Both of the last two terms are divisible by 7. So I'm left with 4x plus 3. Parentheses are the same. What I factored out of the first term, what I factored out of the last term, what they had in common. Okay? Now, what I want you to keep in mind is this is not the only way to factor trinomials with a leading coefficient of 1. On the worksheet that I gave you for homework, there's quite a bit of places for you to add notes in there. One of them is called Guess and Check. You really want to sit and guess and check to see what numbers go where to figure that out, or to figure that out. That would take a really long time. This way there's a pattern to follow. Okay? There are several other names, and I'll show you some of them if you want to see them. Okay? But this is the way that is most familiar to me. It's the way that like I said, has a pattern that I'm comfortable with. And like I said, I'll show you other ways if you want to see them, but this is the way that we're going to mostly talk about it in here. And we talk about it most this way because this goes to factoring by grouping, something that you showed me last week that you're pretty good at. Okay, that you feel pretty comfortable with. So that is how you factor trinomials with a leading coefficient that's not 1. Finish your practice problems on that back page of the handout, and I hope you have a great weekend.